Hi, this is Paul Beckman from DSP Concepts. I'm going to be demoing AudioWeaver running on the ARM Cortex-M4 processor. We'll be using an STM32F407 discovery board. This is a low-cost eval board for one of the more popular M4 processors, and it's readily available online. The interface you see here is AudioWeaver Designer. It comes either as a Windows executable or, for advanced users, as a set of MATLAB scripts. The MATLAB scripts provide additional functionality such as scripting, testing, and automation. Anything I show you today with the GUI can be done in an automated fashion using the scripts. This board has a stereo input and output. The data arrives on the input pin on the left side of the diagram. Audio arrives as two channels with a block size of 48 samples and at a rate of 48 kHz. Data always goes into and out of AudioWeaver as fractional data. In this design, we convert to floating point and then de-interleave into separate left and right channels. This is the default system that AudioWeaver provides for you. I'm going to delete the de-interleaver and interleaver because today's example is going to use stereo processing. The system I'm going to build has bass and treble tone controls, a scalar, and a level meter. Something very basic just to give you an overview of AudioWeaver. AudioWeaver has several hundred audio modules arranged in different module libraries. I'm going to start with the basic Audio Float 32 module library and look for the second order filter module. This is a second order biquad filter with built-in design equations. I'm going to drag the module out and then name it Bass Tone Control. Then I'm going to use the inspector to configure it to be a low shelf. You can see that there are many different types of filters that can be selected, and a low shelf makes a good tone control. I'll next set the cutoff frequency to 200 Hz. This will then boost or cut frequencies below 200 Hz. I'm going to drag out a second filter module and name it Treble Tone. Then, using the inspector, I'll configure it to be a high shelf with a cutoff frequency of 3500 Hz. Next, I'm going to get a scalar module. AudioWeaver has scalars with linear or dB controls, smooth and unsmooth versions, and scalars with single gains or multiple gains. I'm going to use the Scalar dB Smooth module for this application. It has built-in smoothing for clickless operation and applies the same gain to both the left and the right channels. I'll connect all the modules together. And lastly, I'll get a meter module and connect it to the output. I'll then redraw the system and verify that all the wiring looks correct. Everything is drawn as stereo and looks fine. I'm now ready to build the system using the Build and Run button on the toolbar. This sends a design down to the Cortex-M4 board and starts real-time processing. The discovery board looks like a USB audio device to my PC. The audio flowing to the input pin is being played by Windows Media Player. I can also use the inspectors when in tuning mode. I can lower the volume, I can raise it back up. As I'm moving the slider, commands are being sent over USB to the discovery board and affect the real-time audio. We call the process of making parameter changes to the real-time audio tuning, and this is a key feature of AudioWeaver, and it is critical when optimizing the sound quality of the system. I can also tune the tone controls. I'll open the treble tone control and start by lowering the gain. This makes high frequencies disappear, then raise it back up to make it sound brighter. The last feature that I'm going to show you is profiling. It helps you determine the CPU load for your audio design. Go to the Build menu and select Profile System. The AudioWeaver code running on the M4 is instrumented for MIPS and memory profiling, and you'll see that this design takes 10 MIPS or megahertz. You also get a detailed breakdown on module by module basis, and it shows you both the MIPS required and the memory used by each module. This was a very simple introduction to AudioWeaver. If you have any questions, please visit our website or send us an email. Thanks for your time.